Welcome to Ixia product demonstration. In this session, it will be demonstrated how Ixia PCC solution can be used to test the functionality and scalability of a PCE, instantiating RSVP-TE type of LSPs and then sending PC update as and when the topology changes. The topology consists of two Ixia ports connected back to back. On the left-hand side port, RSVP ingress and PCC is simulated along with an emulated router having BGP LS and L3 ISIs. The PCC is running over the simulated nodes that are also running L3 ISIs. On the right-hand side port, there is an emulated L3 ISIs router behind which there is a simulated topology of L3 ISIs nodes and RSVP egress running over those nodes. When testing a PCE as device under test, it will be connected to these two Ixia ports via a network of L3 ISIs and RSVP routers. The PCE device under test comes to know about the entire topology of ISIS nodes by establishing BGP LS peership with the BGP LS speaker running on the Ixia PCC port. It will use this TE database to compute LSPs for instantiating proactively. In this demo, we are configuring Ixia PCE on the same port where the RSVP egress is running, named PCE and BGP LS. Once the PCEP session is established, PCE will instantiate LSPs of type RSVP-TE. Once PCC receives those PC-initiated LSPs and checks their validity, RSVP-TE will signal those LSPs as per the ERO or bandwidth received. One needs to configure on the ingress RSVP router how many PCE-initiated LSPs are expected to be received from the PCE. No LSP configuration is needed on the PCC. The symbolic path name for the expected LSPs configured on the ingress RSVP-TE node must have to be similar as received in PC initiate message. Similarly, the source IPv4 address in endpoint object of PC initiate message must be same as the ingress RSVP-TE address. If these two conditions are not met, LSPs will not get signaled by the ingress RSVP-TE router. The tunnel ID and LSP ID of these LSPs are auto-configured. Starting value of these two parameters are 1 and 1 respectively, and for subsequent LSPs, the tunnel ID keeps incrementing, keeping the LSP ID constant. So it goes like tunnel ID 1, LSP ID 1, tunnel ID 2, LSP ID 1, tunnel ID 3, LSP ID 1, and so on. Backup LSP ID will be used in case of make before break after receiving PC update message from PCE. One needs to be careful while configuring this. Backup LSP ID and primary LSP ID should not be the same for a particular LSP. Let's start all protocols. Now it can be seen that PCC has received PC initiate message from the PCE and all the received LSPs are established by the RSVP ingress router. One can verify how many PC initiate messages have been received by checking PC initiate message received, and if the LSPs are bundled together in a single PC initiate message, one can also see how many total LSPs are received as total initiated LSP received. There is a separate bucket named RSVP in statistics view which shows the different LSP transmit-receive statistics for RSVP type of LSPs. User can verify going up LSP transmit or up LSP transmit as per the number of PC-initiated LSPs received. Since PC-initiated LSPs are by default delegated to the PCE, the RSVP delegated LSP transmit count has also increased. Once PC-initiated messages are processed by PCC, it will ask RSVP to signal the LSPs. User can verify the established LSP details by viewing RSVP-TE learned info as shown here. One can notice the label received and the bandwidth allocated to the LSPs. Now, Once the LSPs are delegated to PCE, it should send PC update message if it detects any change in topology that affects the established RSVP TE LSPs. Ixia ingress RSVP will trigger make before break to re-signal the corresponding LSPs according to the information received from PCE in update message. If there is any error in path details, the LSP signaling attempt by RSVP ingress will result in failure. This way, one can verify whether PCE is able to do path computation properly or not for the LSPs which are delegated to it. The change in topology can be emulated by changing underlying IGP topology, for example, by disabling some nodes or links in the ISIS topology on the egress side. It can be seen that PCC has received PC update message by checking the statistics and the session information at RSVP. In statistics, the PC update receive count has increased as can be seen. Also, the session information shows that make before break is completed. The learned info also shows the changes done. Here the bandwidth was changed by the PC update message. The changed bandwidth can be noticed. Now one can run data traffic over the established PC-initiated LSPs. This is another way of validating that the LSPs have been set up properly and they are able to carry data traffic end to end. If there is any packet loss, that may indicate that the LSPs are not properly computed by the PCE. One can select the expected PCE-initiated LSPs on the traffic source side and RSVP egress on the destination side. After generating the traffic, it is applied and started. The traffic flow statistics shows the traffic for each LSP which is identified by their symbolic path name as shown in the statistics view. So this was all about testing a PCE for PC-initiated LSPs. Ixia PCC solution can also be used to test initial state synchronization done by the PCC with PCE for RSVP type of LSPs. One needs to configure RSVP LSPs at the ingress RSVP as shown. The number of LSPs can be configured as per the scale requirement of the test. Once the LSPs are configured, depending on who comes up first, these LSPs will be reported to the PCE device under test as PC report message with or without the S bit. If RSVP is started and all the LSPs are established before the PCC is started, these LSPs will be reported as initial state synchronization with S bit. Otherwise, these LSPs will be reported after end of sync is sent out by the PCC and the S bit will not be set in those report messages. These LSPs can be delegated immediately after PCEP session is established to the PCE if initial delegation is selected. If this is not selected, then the LSPs will be reported as non-delegated, which can later be delegated on demand while the protocols are all up and running. This is how user can trigger PCEP delegate on the LSPs with delegation state non-delegated. User can also revoke the delegated LSPs by triggering revoke delegation over the delegated LSPs. So this was all about the Ixia PCC solution, which can be used to test a PCE for all types of RSVP TE LSPs as discussed in this session. Thank you for your time. Please watch our other product videos for more information.